after a day of work, you feel exhausted and have a big headache. You get back home and feel so tired that you don't want to say a single word. You close your eyes and feel the pain inside of your head. Anyone? So we see a lot of people here. Oh, you already raised your hand. So this talk is about how to turn brain-hurting codes into brain-friendly ones. I'm Sihui, and I work at a startup called Gusto in San Francisco. We do payroll, HR, and benefits using SaaS, of course. I also blog at Sihui.io, mainly on a lot of software design related stuff, and also share the lessons I learned during my career. So this talk contains 3 parts. First, why some codes just tires us out. Why some codes makes total sense when it's written, but a couple of weeks later when we look back to it, it just makes no sense at all. And how we can turn brain-hurting codes into brain-friendly ones. Last, we're going to look at some code samples together. So another scenario. Let's get ready, it's going to be painful. So at work, you stumble upon a piece of unfamiliar code. You look at it, you don't really know what it does. So there are some couple methods you don't know what it does. You jump on the method definitions, you look at the method definition, you still don't know what it does. So you do a full code-based search and trying to find where else these methods are being used. You read and see how they're being used in all these places. So 15 minutes later, from your coworker's perspective, that's how you look like. Not a really happy programmer. That's the kind of stuff they don't put on the job post. But deep inside, that's how you feel like. You want to flip the table in front of you because that code frustrates you so much. So why? This even happens to code we written ourselves weeks ago. Why some codes just makes total sense when it's written, but a few weeks later, it becomes so hard to understand. It is because the process we write code is very different than the process we read code. When the feature request comes in, we have the big pictures in mind. We know eventually how the code should do in the end after development. During development, we break that big picture down into smaller pieces, into classes and methods. But the process of reading code is quite different. What we encounter is just that small puzzle. If that small puzzle doesn't make sense, we're trying to find more puzzles. We're trying to understand that small pieces by reading all different relevant pieces and putting them together, trying to reconstruct that big picture. We do all of this inside of our head. We use working memory. Working memory is for short-term memory and for reasonings. When working memory gets filled up, we get overwhelmed. Working memory is limited and precious. When working memory gets filled up, all the things that requires reasonings becomes harder than normal. That's where the headache comes from. So it's really having the big picture or not that makes all the differences. It is all about the context we have. When we first write the code, we have the full picture in mind. But when we read code a couple of weeks later, we lost most of that context. We don't remember why exactly we write that code. The piece in front of us is all the clues we have. So the key is really about keeping each puzzle small and also leaving many clues to future developers who are trying to read the code. Before we jump into the house, let's take another look at why brain-hurting code is so bad. Brain-hurting code is kind of like this slide. You don't know what exactly he's trying to say. It requires you to either make a guess or just ask the author. I probably don't know what this slide means in a few weeks. Brain-hurting code is pretty exhausting. Because it's exhausting, it's hard to reason about, which makes it really hard to understand the underlying business logic. As a result, it's hard to discover all the edge cases. Essentially, it just takes away the joy of programming because it makes us less efficient. So how? How do we turn this brain-hurting code into brain-friendly ones? We first start by spotting the brain-hurting codes. If you are the person who's trying to read a code, for example, if you are reviewing a pull request, stay sensitive as you read through the code. If that piece of code, when you're reading it, you have some questions, it's really likely that the next developer who comes in may have similar questions as you have now. If the piece of code requires you to spend about 4 or 5 minutes to figure out what it does, it's very likely that all future developers may have to spend the exact same amount of time. Your goal is to stay sensitive and note down these areas that is not immediately clear to you what it does. The goal is to make the code so clear so the next developer who comes in won't have the same questions you have now. The goal is to save that 5 or 6 minutes of the future developers' time. If you are the person who's writing the code, ask someone from a different team. You need to pick someone who currently don't have the context you have as the person sitting down and reading the code through with you. Also note down the areas where they have trouble understanding. If your coworker have to ask you a question, for example, ask you why you write the code this way, or what exactly you're trying to do with this line of code, instead of answer the question immediately, ask your coworker what he thinks that code is trying to do, and work with your coworker together to make that code so clear that the next developer who comes in won't have the same question. So after we spot these brain-hurting codes, how can we turn them into the brain-friendly ones? Again, the key is about to keep each puzzle small and also leave many clues for future developers. Small meaning doing exactly one thing at a time. It means breaking a big picture into small parts that make sense. Leaving many clues means write code as if you are writing English. Ruby is a very descriptive language. It should be read as if you are reading English. It means let your code tell the story. When your code tells the story, it immediately explains what its intention and what it's trying to do. When the code does that, the developers don't have to spend too much effort into understanding what the code is trying to do. They can instead focus their effort on understanding, to reason about the underlying business logic and see if there's any edge case that haven't been covered yet. So we're going to look at some code samples together from the Discourse open source software. Is this clear enough? Cool. So here we have a handle chunk upload class with the check chunk method. Inside this check chunk method, it first checks this condition. If this condition is true, we're going to return 200. Else we're going to return 404. When I first read this code, the first questions I have is, what exactly is this condition checking? It seems like it first checks to see if the chunk exists in the file. If so, it then goes on checking to see if the chunk size in the file is the same as the current chunk size. Seems like it's trying to see if the chunk is in the file. And combining the name of this class, which says handle chunk upload, seems like what exactly it's trying to do is to see if the chunk has already been uploaded or not. So instead of having all other developers who comes in have to go through the exact same process I just did, let's just give this conditional a name. Now the code is pretty clear that it says, let's first check, has chunk been uploaded or not? If so, returns 200, else returns 404. The next questions I have is, exactly what are 200 and 404? Are these just numbers, or they actually mean something? Coming from a web development background, I would guess these are actually probably status codes. So let's just call them starters. So the next developer who comes in don't have to guess what they mean. Now the code speaks as if, first we check to see if the chunk has been uploaded. If so, we're going to return 200 as the status code. Else, we're going to return 404 as the status code. If you want to be even more clear, you can even leave some comments. This is how this code looks like in the actual code base. It says, check whether the chunk has already been uploaded. If so, returns 200 to represent the chunk exists. Else returns 404 to represent the chunk has not been uploaded yet. Clear writing actually requires clear thinking. In the process of refactoring, trying to make the code more clear, it's actually the process for us to gain a deeper understanding on both the problem and the solution. When our thinking becomes more clear, our code gradually becomes more clear as well. Now let's look at another code samples together. Cool, so this is another class from the Discourse software. It's in the category list class. It has a method called find categories. The first part of the method just finds all the categories. We're going to ignore this part and focus our attention on this chunk of code. It's not immediately clear what this chunk of code does. So let's try to read it line by line. First, iterate through all the category within the list. So C actually stands for category. Now, as the reader of the code, I have to remember C stands for category. Then it tries to get the topics by category ID. And then it tries to see if the topics in category are actually present. If so, we're going to clear out all the displayable topics associated with the category. Then in here, we're trying to get all the topic IDs from topics in category. Here is actually a surprise to me because I thought topics in category has a list of topics. Seems like topics in category actually has a list of topic IDs. So let's note this down as well. Next, we're going to get the topic by the topic ID. And then we're going to check this condition. If this is true, we're going to actually do something. So this is what we are actually doing here. So what exactly are these two lines of a code doing? Seems like it's just associating the displayable topic with the category. So let's note this down as well. So this chunk of code is actually fine as it is currently, the way it is. But we have to read through about 20 lines of code to understand what it does. What would be really nice is if the next developer who comes in can just glance at the code and know exactly what it's trying to do. So let's try to make this code more readable and more easy to understand. We can start by changing the small things we notice. First, let's update C to category. So the next developer who comes in don't have to remember C stands for category. Next, we can rename topics in category to topic IDs in category because that's actually what it contains. Now, let's try to refactor this code from the inside out. Here is actually where the action happens. As we discussed before, what it does is just trying to associate topics with category. So it would be really nice if we can just tell the next developer exactly what it's trying to do here. So we achieve that by giving a name to these 3 lines of code and turn it into a private method. All right. Now, if we take another look at this code, the next questions I have is, what is this condition checking? It's trying to see if the topic is present and if the guardian can see the topic. If that's the case, then we add the topic as a displayable topic. Sounds like it's checking to see if the topic is displayable. Again, let's give this condition a name. So now the code becomes, first we check to see if the topic is displayable. If the topic is displayable, we're going to call this method. Now if we take another look in the outside of this code, it seems like we are not actually interested in the topic ID. Topic ID is just a way for us to get to the topic. So it would be really nice if in here, instead of topic ID, we have the topics. That means we need to have a list of topics in the category. So how do we get to the list of topics given the topic IDs? Well, we can just call this method and map each topic IDs using the get topic by IDs. Next, taking another look at these lines of code. Sounds like we are not interested in all the topics. We're only interested in the displayable topics. So here, it would be really nice if we can just get a displayable topic directly. That means that we need to have a list of displayable topics already. So again, how are we going to get a list of displayable topics given we already have all the topics in that category? Well, we can just select the topics that's displayable using the condition we found. Then in here, we don't actually need to check the condition because we know that all the topics that's given are displayable topics. Before we move on, let's take a look at these 3 lines of code. Earlier, these 3 lines of code, they are kind of spread out across this method. Now, taking another look, we notice these 3 lines of code are actually trying to achieve the same thing. They work together to achieve that one goal, which is just trying to give us the displayable topics. So let's just tell the user what exactly we are doing here. So here we are doing get displayable topics for this category. Again, we can just move that part out into its own method. Now let's go back to this part of code and see how we can make it even more clear. If we say here we are trying to associate displayable topics with this category, seems like all this chunk of code doing is trying to associate all the displayable topics for a category, given the displayable topics. So we can just tell the user directly that's what we are doing here. So we're trying to associate displayable topics, given a list of displayable topics. And then we can move this part out. Now let's take a final look at this chunk of code and see what exactly it's doing. Seems like the first part of code just finds all the categories. And then here we're just going to associate displayable topics for all the categories. Again, let's just tell the user, tell the reader of our code directly what we are trying to do so they don't have to read through this code. Here, actually, we're just trying to associate displayable topics. Uh-oh. Here, actually, we need to indent this part out. Now, if we take another look at this method, it's pretty clear that the first part of the code just trying to find all the categories, and then later we're trying to associate displayable topics. The difference between the refactor code and the original code is that the original code tells the user how a task is being accomplished. It lists out exactly how this task is being accomplished, but it doesn't tell the user what the task is and why we're trying to do this task. The refactor code first tells the user what the task is, which essentially is the big picture. And then if the user is interested to see how this task is being accomplished, then they can go down into this method and see exactly how it's being accomplished. In the software world, we talk a lot about making our product as user-friendly as possible. Code is actually written once, but read many times. As a developer, your users are actually the people who read your code, your fellow developers. Writing brain-friendly code is about being thoughtful about the reading experience of your code. When you write brain-friendly code, you provide a better reading experience for your code. So let's just write code that's brain-friendly. You can find the slides on sihui.io/brain-friendly code. And you can also find me on my website or just follow me on Twitter. Or just go talk to me. Thank you.